Good morning. My name is Matteo Parrucci. I work at the Bologna University Science 2008, and today I will tell you how and why we integrated Matomo Analytics with our Plone sites. Just to clear the naming issues, Piwik just recently changed name to Matomo. I'll be using them as equivalents. We are inside the cinema, so I replaced all the usual kitten images for presentation with images from my favorite movies and shows. And you can try to guess the titles. Well, some number. Bologna University is the older Western university and was founded in 1088. It apparently aged quite well because you can see the numbers, they are quite good. And I'd like to focus obviously on the web traffic. As you can see, we had almost 150 million page views last year. And the current year projections tell us we will probably reach 175 million this year. We are a team of 6 developers, of which 4 works on Plone, and the other 2 works on the app, digital library, and the internet, that are services which are not written in Plone. In the picture, you can see it's the 6 of us like trying to smash the code to our needs. As I said, we are 4 on Plone, and we manage 29 Plone sites and a total of 2,000 subsites, because we have a multi-site architecture where subsites are created inside the Plone site. We have a total of around 400,000 pages edited by 4,000 editors. And we received almost 100 million page views last year on Plone sites. And before diving into it, I would like to ask you a question. I'd like to raise, if you could raise your hand if you use any form of web analytics at all. Okay, almost everybody. And now keep it raised if it's not Google Analytics. Okay, and keep it raised if you host your own analytics data. Okay. Why should we care about analytics at all? I just saw almost everybody raise their hand at my first question, so maybe this slide is not super useful, but still, why should you care about analytics? Basically because it allows us to monitor the goal-related metrics and help us to understand what works and what doesn't on our websites. So we can act in order to achieve our goals. It's an iterative process, so basically it never ends. If it's so important, why almost everybody outsource it? Well, I'm not gonna lie. All of these points are true. It can take a lot of disk space, it can use a lot of CPU time, and it's another piece of software to be maintained and updated and everything, and taken care of. And yes, all of the above are a pain. So why do we decide to insource it? Well, basically because we could not afford to lose any data at all. And the third-party services can change terms, like Google Maps did just last year. And I saw a lot of this map is broken. Or even worse, can be shut down at all. We could not afford losing any historical data. Also, we needed to be able to recover from broken JavaScript or anything that could interrupt the flow of the hits. The second reason is that we needed accurate data, and almost all third-party services does data sampling. And data sampling works like more or less like exit poll. You select a sample that is a subset of your traffic, and you try to estimate the overall result based on these numbers. This, in our experience, was not accurate enough. So, why did we decided for Matomo? Well, that's an easy question because it was and still is, the leading open source analytics solution. And it already had such stories with websites with big numbers. Also because it's very modular and its plugin structure allows to easily customize aspects if needed. And it allowed us to recover from lost data by parsing the proxy logs in a second later. And let's see how a Matomo profile is structured. Well, it has obviously a profile name and one or more URL domain, public domain, to track. Also, it has some optional parameters that are specific to the website, like the query string parameter name for internal searches, so that Matomo can identify the internal searches, for example. And for every created profile site, Matomo assigns a unique site ID. And now let's discover the Matomo user. Obviously, it has an email, username, and password, and it can have read, write, or admin permission on every and each of the profiles. So basically, we have a permission matrix with users on the rows and site profiles on the columns. We used profile proxy user because bringing the LDAP madness complexity inside Matomo didn't seem like a smart move. For every created user, Matomo assigns a token, the token API, an auth token that is used for API requests. And now the integration. The first step for the integration was to create a behavior. As I said before, we have a multi-site architecture where a user can create autonomously web subsites inside the main Plone site. So we developed a behavior on the subsites that holds 4 fields basically at the moment. The domains, the URLs, and a flag that enable or disable the tracking code from the site. The other 2 fields are the auth token and the site ID, and will be automatically populated by our script after the Matomo profile and user have been created. So let's see some more about the script. This script runs on a daily basis and reads all the behavior fields from the subsites, from all the subsites. If needed, it creates or updates the Matomo sites and site and user, and write it back the site ID and the auth token in the behavior read-only fields. We will need this data to show the dashboard and to show the tracking code also. On Matomo, we developed a few plugins because, as I said, it's very modular and easy to integrate. In detail, we created some custom widget that holds some specific statistics that we needed to show, and some dashboard. We developed more than one dashboard because every Plone site has a different subset of data. So all the subsites at the moment share the same dashboard. And we wrote a couple of views. A viewlet that is registered on star and holds the tracking code, the JavaScript tracking code inside, and needs the site ID to show the JavaScript. And another view that is registered on the behavior interface, it basically shows the Matomo dashboard inside an iframe. And it passes to Matomo the auth token so that the permissions are strict, and the site ID that we want to show. We prefer to use an iframe solution to give editors a fully integrated user experience inside our Plone site. Now I'll briefly explain how Matomo receives and processes data. Matomo basically receives async JavaScript request from the browser, from the Matomo JavaScript in the specific, and saves the raw data into the DB, into a temporary table of the DB. After this, it responds to the request. A CPU-intensive scheduled parsing process takes care to read all this data, analyzing it, and write back in the DB the structured data that will be shown to the users. And now the data are ready to be shown. What was for us the problem with this process? Well, it's quite simple. When Matomo is under heavy load because the parsing process is heavy and is constantly running, it can be slow to respond to the tracking request, leaving the browser hanging. And this was not the main reason. The main reason for us was that sometimes Matomo reaches the timeout and we basically lose the hit. And as I said before, losing data for us was not an option. To avoid this, we created a Redis queue that is fed directly from the proxy. The proxy immediately answers to the request without leave it hanging, and adds the request to the Redis queue, so it doesn't need to call Matomo. After this, we wrote a Python daemon that reads from the queue and sends Matomo the bulk of requests, handling failures smartly. And by handling failures smartly, I mean that if the Matomo raises a timeout, we put back the requests in the queue so we can replay them after. This way, we avoided to lose data, and as a bonus, we sped up the whole process because Matomo is really faster using bulk insert because it makes one insert of 10 rows instead of making 10 insert of one row in the DB. That is the bottleneck here. And now some statistic about the statistic system. We are going like meta statistic here. DB and Matomo shares the same hardware, and you can see the specs on the slide. It's not really a supercomputer thing. And with this number, we can manage 17,000 Matomo users, and we track up to 2 million hits per day in the busiest days. They are more than 23 per second. These requests are spread on 18,000 websites, and the full parsing process takes on average 8 hours, so we have fresh data 3 times each day for each profile. The storage is, at the moment, more or less 100 gigabytes per year. And let's see the result. This is a dashboard. It contains all the things you would expected, and it's inside the Plone site. So you have the date range selector, the evolution of unique visitors and visit over time, the source of traffic, the most viewed pages, the kind of device that is being used, the geolocation of the visitors, the exit pages, the downloads, and anything else. Future developments. As future developments, we would like to centralize the management of the general purpose JavaScript using the newly released Matomo Manager, Tag Manager, and that mimics the Analytics Tag Manager by Google. We would also like to allow dynamic per profile setup, adding fields to the behavior so that you can set up also the custom parameters. And also, we would like to add a selector to select which dashboard you want to show on a sub-site level. Because now, as I said before, it's on a Plone site level. So all the sub-sites at the moment have to share the same dashboard. Under the structural point of view, we would like to better balance the load by creating 2 MariaDB servers in a master-slave configuration. And this would allow us to also split the Matomo server into backend and frontend. So the frontend reads the data and shows the dashboards reading from the MariaDB slave, and the backend writes and does all the heavy lifting, writing to the master MariaDB. If you have any question, also here you have the solutions to the quiz, to the movie quiz.
Any question or curiosity? Tough.
Thank you. Really great example on how to use Matomo. We use two, but not at your level. The question is, you intercept the request at the proxy level. Did you find difference in counting using this approach instead of using direct access? Basically, if you have the JavaScript interacting directly or not, or just using the proxy server. This is my first question. And second, you focus a lot on not losing data. So is there a particular matter on your institution to do so? Thank you.
Well, we have to provide data for institutional reasons. That's why we can't lose any data. And the first question, we intercept the request at proxy level, and we noticed that all the like 2% of difference we have in the statistics, more or less, for the timeout that Matomo gave before. So we measured the failure rate by reading the Matomo logs and seeing when it was raising the timeouts. Okay.
Is there any other? Yeah, coming.
Thank you. This is a very, very interesting, very enlightening implementation you've got. Is your code for getting all of this working with Piwik or Matomo open source? Is that something that we can use?
Yeah, I hope somebody asked this question. I have a bonus slide. We'd love, but now it's a very vertical solution. If somebody want to, we are open to open the code base if you want to collaborate. And yeah, so it's basically available, but very specific at the moment.
Okay, great. Any other question? We have time. No? So.
Here are my contacts if somebody want to ask something in private and the presentation URL. Have a nice day.